Hi everyone, so continuing from our last video that I kind of cut off quite suddenly, I just wanted to look at the 4 rules again that we need to know. So the first rule is that some base raised to the power of x has to equal a number b. So it's like how I showed you with the little snail method, so that x is equal to log base a of b. So this would be our exponential form right here, a to the x equals b, and this would be our logarithmic equivalent. So it would be x equals log base a of b. So basically what that's saying is that some number, some base raised to the power of x will equal b, and then it's saying that the power is going to equal the log base a of that number. Alright, so we know that our answer to any logarithmic expression, if I have log base a of a to the x, I know my answer will always be x. And I also know that if I have some base a that's raised to the logarithm of base a of x, my answer there will also be equal to x. And a logarithm base a of a will always give me the number 1. So those are 4 things that you absolutely need to keep in mind when you are looking at solving your logarithmic expressions and so forth. Okay, so if we want to just very quickly take a look at again some of the examples. So if I have 2 to the negative 3 equals 1/8, and I wanted to rewrite that as a logarithm, then as a logarithmic statement it would be log base 2, of 1/8 has to equal negative 3. If I wanted to rewrite 2 to the power of 6 equals 64 in a logarithm, or as a logarithm, then it would be log base 2 of the number 64 has to equal 6. Remember that we are looking at, if we were looking at this as that snail sort of explanation, it would be like saying 2 raised to the power of 6 equals 64. So if I had to find log base 9 of 3, well, what that's basically saying is, so if I have log base 9 of 3, so I've got that 9 raised to the power, so I will set this equal to x, I will set this equal to x, and I will set this equal to x in all 3 questions, and I'm basically saying that 9 raised to the power of x has to equal 3. So that becomes 3 to the 2x is equal 3 to the power of 1, and therefore my value of x would go to 1/2. Okay, so because I'm going to disregard my bases and I just left with my exponents. If I have log base 9 of 9 equaling x, well, I know my answer has to be based on the rule that we said log base a of a has to always equal 1. So in this case it would always be equal to 1. And frankly it would be like saying, I could work this out, and it would be like saying 9 raised to the power of what equals 9. 9 raised to the power of x gives me 9. That value can only be 1. And if I have log base 2, so that would mean I would have 2 raised to the power of x equals 0.125, and I can figure that out as, how would I rewrite 0.125? So that rewritten, this would be like saying 2 to the power of x equals 1/8, and x is 2 to the power of x equals 2 to the power of negative 3, where my value of the x would equal negative 3. So if we look at a few more examples, now questions can get a teeny bit more complicated as we start looking at some of the possibilities here. So we've got, okay, the first one is quite simple, so that if I have log base 2 of x equaling 3, well, that's really saying 2 raised to the power of 3 equals x, and 2 raised to the power of 3 equaling x tells me that x is just equal to 8. And if I have 2 raised to the power of 2.5, that will equal y. And so I will just do 2 raised to the power of 2.5, and I get 5.68, or approximately 5.66. If I were to do log base 2 of x minus 6 equals 3, well, that's really like saying 2 cubed, or 2, if we want to use the rule, it would be 2 raised to the power of 3 has to give me the entire expression here, x minus 6. So 2 to the power of 3 equals 8, not 6. And so that equals x minus 6. So that 8 is equal to x minus 6, and so that x would equal 8 plus 6, which is 14. And then the last one would be 1/2 raised to the power of y equals 1024. It's like saying 2 to the power of negative y is equal to 1024. And I believe that we would end up with 2 to the negative y equals 2 to the power of 10, so y would equal negative 10. So that's done. The last one is done as well. Now, just keep in mind that when we are working with our calculators, so with our calculators, I showed you with the calculators that we are looking at, if we're taking the logarithm of base 10 of 152, so let me just close this, close the log of, so if we want to take the log base 10 of 152, we could do this in two ways. So the first way is, because we know this is already a base of 10, because it tells us here that it's a base of 10, then all I would really have to do is just say log of 152, close the parentheses and press enter, and I get 2.18. The alternative, now if this was not a log base, if this was not a base 10, then I would be able to also work this out. Going again into my calculator, I would go to the math button, and I would go onto log base, enter, and I would do log base 10, and then move it over to 152 here, log base 10 of the number 152, and I still get the same answer of 2.18. So it's two answers, two ways of reaching the answer, but because in this case we know that it is a base 10, then I don't need to use the log base button, but I can just use the regular log button that is here. I'm indicating it, the log base button here, that is directly on the calculator, because it is already evaluating the base 10 for me. Alright, so if I were to do log base 3 of 27, well, again, I could change this into an exponential function first, an exponential expression first, and in this case it would be 3 raised to the power of x is equal to 27, and I know that x has to equal 3, because 3 to the x is equal to 3 cubed, and x equals 3. If I were to do log base 5 of 2, well, that's like saying 2 raised to the power of x is equal 5. I can't bring these down to the same base, so I'm going to count on my calculator at this point, and I'm going to go to the math button. I will click until I get to log base. I will press enter, and then from there I will place in there log of 5. So I will place log of base 5 of 2. I believe that's what the question was. Yep. And that gives us 0.4306. So it goes to 0.4306, or simply 0.43. So 0.43. If I were to do log base 4 of 64, that's like saying 4 raised to the power of x has to equal 64, and this actually can all be brought down to a base 4, or I could bring it down to a base 2 automatically. But if I leave it as a base 4, then it would go 4 to the power of x is equal to 4 to the power of 3, and x equals 3. So my answer goes to 3. All right. So when we write, or when we work with base 10, we usually do not write the base down. So when I write down log of 25, that really means log base 10 of 25, which written as an exponent would mean 10 raised to the power of x gives me 25. And if I write log of 100, well, that really means log base 10 of 100, which if I rewrite again as an exponent, it would be 10 raised to the power of what will give me 100, and that value would be 2. All right, so here we've got a few examples, like log base 10 of x equals 2, so it's 10 squared equals x equals 100. And if I do log of root 10, well, it's like saying 10 to the power of x equals 10 to the power of 1/2, because 1/2 is like saying the square root of, so x equals 1/2. And if I've got log base 10 of negative 5, log base 10 raised to the power of negative 5 will equal x, so that would go to 0.00001. All right. Now, the very last thing I just want to mention, and I will stop there, is that the most common logarithms that we deal with are going to be in base 10, but sometimes they're also in base e. What does base e mean? Base e is nothing more than another special type of base. So instead of calling it base 10, we have a new base that is written as e, and that e stands for a number which is 2.718. So 2.718 is a base. So if I say e raised to the power of x, it's 2.718 raised to the power of x. Now this is a very special number, and this number is used a great deal in financial math and when we're compounding and so forth. The e value comes up a great deal. All right, so if I have log base e to the x equaling 5, that's like saying e raised to the power of 5 gives me x, which is like saying 2.718 approximately raised to the power of 5 is going to equal x, and you can work that out on your calculators. All right, so I can do also e raised to the power of x equals 6. So e raised to the power of x equals 6, and what I would do is I could use trial and error here and do e raised to the power of different values for e until I hit the number that will give me 6. So I'm assuming that if I do e raised to the power of 2.71, because that was my answer, I would get, let me just check, second function e raised to the power of 2.71. That definitely does not give me x. Okay. So it would be, let's see. So what I could do is I could open up my calculator, and since this is like saying log base e, if I rewrite log base e, if I rewrite this, I could put this directly into my calculator as log base e of 6. So I go into my calculator, I go to the math, I go to log base, I press enter, and I go to second function and I press the division button, which gives me, the second function. So it'll be second function and then the button for the division, which will give me the e, and then that will be raised to the power of 6. And when not to the power of, but it gives me a value of 6. So e raised to some power will give me 6. So I get my answer to be 1.79, and there's my answer. Now I have another method that you could do this, but I will not show you this one until next time. All right, so this is it for today's lesson, for this moment. We'll drop it right here, and we'll pick up next time.